In the previous episode, we realized that a Firebase project is actually a GCP project under the hood, and that data stored in cloud storage can be equally accessed via Firebase-powered mobile apps and web clients, as well as from your GCP-hosted applications. In this episode, we'll explore two more products, Cloud Functions and Cloud Firestore. Stick around. Cloud Functions is really a Google Cloud product, which also happens to be visible from Firebase. Cloud Functions is a popular implementation of the Functions as a Service paradigm, where an event in a system, such as an HTTP call or a file uploaded to a bucket, triggers the execution of a small piece of code, a function. Check out the Serverless Overview episode for more details on Cloud Functions. An important architectural difference between the Firebase and GCP approach to Cloud Functions is that Firebase will offer you to wrap your functions into callable functions. Such functions can be invoked via the Firebase SDK with user tokens and device instance IDs propagated directly to the function. Another important difference is the languages supported. When using Firestore, Node.js and TypeScript are supported, while Go, Python, and Java are also available when using GCP Cloud Functions directly. Before we compare web consoles, you can also use command line interfaces, gcloud or the Firebase CLI. Both come with their own set of functionalities, and it's recommended to decide which one works best for you and stick to it. To deploy functions with Firebase, you'll need to install Firebase command line tools using npm, as deploying from the Firebase console is not possible. In GCP land, you can deploy functions straight from the console, integrating with GCP's private source repositories, or even typing the function source code inline. Firebase command line tools do, however, come with an API for strongly typed handling of some trigger events, and with the ability to deploy multiple functions at once. Just as you would expect, a Cloud Function created with a Firebase project can also be managed using Cloud Console. In fact, clicking on Detailed Usage Stats in Firebase will take you to that same function, only in Cloud Console, where you'll get additional features such as monitoring graphs, a tab to test the function, and the ability to set features such as retry on failure, memory allocation, or timeouts. Whichever way you use Cloud Functions in your Firebase or GCP architecture, they're likely to be very effective at what they do best: small tasks in reaction to all sorts of events. Cloud Firestore is Google's state-of-the-art NoSQL document database. It is schemaless and offers to store documents containing attributes in a hierarchy of collections. It is fast, it supports transactions, it's highly available, strongly consistent, and it does not require managing any kind of infrastructure. Some will say it's a serverless database. Cloud Firestore comes in two flavors: Data Store mode, which is mostly suitable for server projects, and native mode for mobile and web apps. Let me focus here on the native mode, which is the one that is common to Firebase and GCP users. This mode can automatically scale to millions of concurrent clients, but what makes it even more special is the fact that it offers near real-time notifications. This is what enables synchronization of data across devices. With its built-in offline support, you can access and make changes to your data, and those changes will be synced to the cloud when the client comes back online. Data stored in Cloud Firestore can be accessed using Firebase SDKs, and of course, you can use either console to view and edit data and indices, and to monitor database access usage. With Cloud Firestore, you can query the database directly from your mobile or web clients without the need to set up an intermediary server to manage access to your data. And this is why the Firebase console has an additional tab for security access rules. If you are a Firebase user shipping an app that accesses Firestore, then you really should use Firebase authentication and think carefully about your security access rules. On the GCP side, there are no equivalent security rules, as you typically access Firestore using a service account. Generally speaking, server-side code is considered trusted as opposed to client code from mobile apps. Finally, supported Firestore SDK languages include Python, Node.js, Java, C#.NET, Go, PHP, and Ruby, with Firebase mobile SDKs adding web, Android, and iOS support. These mobile Firebase SDKs include local caching as a unique feature to help implement the offline capability that I mentioned earlier. Same project and billing infrastructure, common cloud storage, Cloud Functions, and Cloud Firestore services. The two platforms have a lot in common. So whether you're a GCP developer interested in building mobile and web apps with Firebase, or a Firebase user trying to grow your usage of GCP services, you should now have a good sense of what's possible. It's time to get going with Firebase or GCP or both. Thanks for watching this video. Please like, subscribe, comment, share, and look forward to more GCP Essentials videos.